Once again, my name is John Gottula, and as Dr. Tedeschi said, I'm an analytics advisor at SAS. My background, however, is in agriculture. I have a doctorate in plant pathology and a bachelor's in horticulture, and I came to analytics rather later in my career, following more of an academic background. So it's wonderful to be here. The challenge I was given for this workshop, for this symposium, is how do we build a chatbot that is knowledgeable of your research? And so that's what we are going to do today together. And so I would invite all of you to participate in this hands-on workshop. By a show of hands, who here is planning on participating in the hands-on portion of the workshop? Great. Keeping hands up, who among you has received an email welcoming you to a compute environment from SAS? Okay, great. Is there anyone here who intends to participate, filled out the Google form, but has not yet completed the steps to do this? Okay. Tom, if you wouldn't mind discussing. So, hands up, make sure Tom finds you so that you are able to log on. We will troubleshoot right now to the best of our ability to ensure that you get on. For those of you who would like to learn more but haven't yet signed up, we would ask you to find a friend here in the audience to look along as they do the steps. To an extent, this is going to be a build your own or choose your own adventure type workshop. And so though we have selections kind of pre-built for you in the GitHub environment, you will be able to type in your own prompts to the model and that type of thing. Okay. The other thing I would like to mention before we begin, for those of you who do intend to follow along, there is a click path available in the GitHub link for this workshop, the same GitHub that has been available for the other workshops in the symposium. If you don't have that handy or don't want to work off of a split screen on your laptop, I would invite each of you to come to one of the first two clusters of tables so that you're able to see what's going on, because some of the things on the screen will be relatively small today, and we won't be able to zoom in at every step. So we'll be setting up for another 10 or so minutes, so I would invite you to bring your laptops closer so that you may see the screen. Okay. Building a customizable chatbot using large language models. For those of you who opted to participate and signed into the Google form prior to July 5th, we asked for, what are your goals with this workshop? And I summarized these into kind of three clusters, three areas that people are interested in for this workshop. Just to level set, you know, Tom and I work for SAS Institute with DataStep and Proc Mixed and Proc Glimix and things that you're familiar with. This won't be that type of workshop, right? This is how people are using commercial grade SAS on the cloud to build their own chatbots within large language models within Fortune 500 companies, right? So we're not going to tell you about different links and distributions and Proc Glimix today. It won't be a stats class, for better or worse. Though I'm more than happy to speak with each of you throughout the conference. I'll be around the next couple of days to help you with those types of models. Okay, so the three buckets that people are interested in are, is there anyone else who has signed up but needs help getting on to the environment? Tom has bandwidth. Okay. At any point during this workshop, if you need assistance, if you're lost, raise your hand and we'll be around to help you. One of us will be around to help you, okay? Okay, so there are three buckets of things that people were interested in. The first in red is understanding text. How can I pick the most important, most impactful article to read for a literature review, for example? Or how do I use large language models or chatbots to diagnose coding errors and improve my coding, right? To me, those are things that are deductive. They can take information from a broad swath of text, including coding text, and deduce it into this is the paper you should read, or this is the bug in your code, right? It's a very deductive process. Another group of interest in orange here is generating text. And in this case, sometimes people weren't specific about what exactly they wanted to generate, but you more said who you want to generate it for. You want to generate it for your students, to create learning materials within your course, or you want to generate it for the purpose of agricultural extension, being able to crisply communicate cutting-edge research information in a way that the consumers of that information could be able to digest, which I think is a strength of chatbots / large language models. Thirdly, and by far the biggest point of interest was, well, I want large language models to be able to help me do whatever I'm working on today. And so that can be extrapolating information from structured text or research data, such as experimental data, or precision ag, or real-world evidence, whatever you want to call it. And those of you who responded named various subdisciplines or areas of your research work that would very much fit into that. On the other side of the world is working with less structured data. And so it might be drone data or other forms of data, and being able to either infer from that data or generate a new model from that data. After all, those two things are two sides of the same coin. To create an inferential statistical model is to create parameter estimates that you can then plug in the X variables for to solve for Y. The very same way a generative model can infer meaning from unstructured text and then generate new patterns of words based on each concurrent word's statistical association with the other. What would you add to this, Tom?
I would add that we're going to try to get Dr. Tedeschi signed up. It'll only take a second.
Yep.
And just keep doing what you're doing for a second. Yes, here we go. I'm going to resend that email. Okay, beautiful.
Yep. So, for anyone who intends to follow along, we'll get started in a few minutes, but make sure you follow the instructions in your email to be able to log on to the environment. Okay, so generative AI, that is large language models, chat GPT, that type of thing, is a subset of AI. And before I turn this over to Tom, let me just mention that many people familiar with SAS are familiar with SAS statistics. And to us, to Tom and I and our 12,000 or so colleagues at SAS, we see this as a continuum, this chatbot thing as a continuum of what we've been doing as an independent company for 49 years, right? So whereas you may be familiar with, again, SAS for statistics, we see that as a subset of the machine learning discipline, subdiscipline within artificial intelligence that functions as a continuum with neural networks and generative AI that then also intersects with natural language processing, which is a feature that SAS has been supporting private industry and governments in for many years, not necessarily so much on the scene in colleges of ag yet. So what you may be seeing today, what you will be seeing today may be new to each of you for SAS. Tom. Okay.
Hey folks, it's such a pleasure to be here today and chat with you. I'm not used to being behind the podium. I'm used to like running around the floor when I'm doing this, but I'll do my best from behind the podium to walk you through all this. We are thrilled. Well, I'm thrilled, I should say. I'm thrilled to be doing the stuff that I've been doing for years in the context of large language models, which is this whole new innovation that was just kind of building and building until it really broke into mainstream. We all remember what those experiences were with our first forays into large language models, I imagine. First time you chat GPT'd anything and got a response that was at least meaningful, though not necessarily in line with the exact question you asked. Nowadays, like being able to point a large language model to your data and be able to get answers that are relevant to the questions that you have specifically is so paramount, and we're going to show you how to do this today. Just talking about generative AI as a subset of AI here, so this is where I've been spending so much of my time in natural language processing, and that's like the ability to essentially, in my case, use linguistics rules with statistical capabilities. I mean, it encompasses everything here. I've done it from the perspective of machine learning. We've used deep learning to look at, oh my gosh, I used deep learning first with folks from the FDA to assess essentially adverse events related to drugs which could cause serotonin syndrome and get at the bottom of the actual combinations of symptoms which actually produced serotonin syndrome, like related to drugs. And now we can ask those questions just of our data using a chat interface. It's fantastic. So a lot of what I'm doing is still what I've been doing all along, but now having this layer of like interpretability into the questions that you're asking and the results you're getting is really game changing when it comes to trying to assess vast amounts of unstructured data and try to get questions of that in many different domains. So what we're going to talk about here is a bit of a hybrid approach, where on one side we have generative AI, and that's like just when you go to like chat GPT. You're using machine learning. It essentially is that subset of machine learning as we discuss. And it goes through essentially an algorithm, and it extracts key features, relational concepts, and generates novel text based on your data. Now, what I'm going to add to this is capabilities that we've been doing for years related to linguistic rules and traditional text analytics. Essentially, this goes a little bit beyond search, too. You can point what, in our case, we use information extraction models to identify subsets of your data that are relevant to a problem. And when you take all that data and you compress it down to this and you give that to the large language model to ask a question, it's so much more focused. A good example is this. If I'm looking at inspection reports related to food safety, and my main question in mind is how can I help grocery establishments prevent a pest infestation, or how can I point my inspectors into the right places to spend their time where the issues are actually occurring? Am I going to give all of the 90,000 inspection reports I have over the last 20 years to the large language model? What I could do is I could run an information extraction model, and we'll show you how to do that, that just grabs essentially in each statement, is there a serious issue occurring? We say serious issues are some kind of infestation. And is it in the context of where the issue actually occurred? So basically, give me all the actionable information. And that might be just a small subset of my data, like let's say 2% of my data. Feed that to the large language model, and then ask your questions of that. And we found that you can get much more accurate responses using less data using this kind of a hybrid approach. So with that, I'm going to turn back to John to talk a little bit about enterprise spend in terms of what do the numbers mean. See John running over to this side of the room again. So And then we'll get right into the workshop, and we'll be able to walk you through each of the steps.
Okay, so to establish the relevance to this, what we've seen in private industry is all of the IT department suddenly putting enormous resources into large language models since ChatGPT hit the scene in a big way in late December 2022. And so where is this money going? There is a certain portion of dollars going into servers, so data centers, cloud compute environments, that type of thing. An enormous amount of money going into software, right, projected to be $226 billion by 2027. So that's the slice of the pie that our business model is to participate in. And then, but even, and importantly for those of you entering potentially the private sector workforce in this room, public sector as well, services is projected to be bigger than either of the other subsegments of this AI spend in IT departments. What is services? Think consulting. Anything pertaining to consulting, AI consulting, implementation, that type of thing. And most of these consulting services are small to medium-sized companies, right? And so to be able to get into a company or an organization to understand what they do, what their business is all about, what their data is, what their users need, that we understand as subject matter experts, as animal scientists, right? And also having the knowledge of IT systems and how to architect a chatbot, right? That allows us to provide enormous value to implement the computing potential from these data centers, empowered by the software tools available, to become useful for the business or operational goals of these organizations. And so the forecast for this is to grow, just continue growing enormously for the next 5 to 10 years at least. And I take this as a fact because so many IT organizations have allotted major portions of their IT budgets to implementing large language models today. However, what we have seen since that kind of influx of money into large language models since 2022 is, lo and behold, and those of you who teach undergraduate courses and see undergrads use these tools can probably relate to this. Gosh, chatbots, large language models aren't always the best at what they do. They don't always give you the right output. I mean, they may give you a completely wrong output sometimes. And that's what we see in corporations as well. And so 66% of leaders, according to industry consulting organizations like the people who study this stuff, 66%, 2/3, are dissatisfied with their progress on AI or generative AI. Okay. So, how can we use the benefits of large language models, such as to make data understandable for lay people, for the non-data types, or for people who don't know that specific discipline or industry? How can we take those advantages and make the model hallucinate less, make it more precise, tune it to the research that we have in hand, right? Be it for frontline leaders making decisions every day in industry, or students, or our extension stakeholders. How can we bring the best of our research together with the enabling capability of large language models? And so part of the SaaS roadmap, product roadmap, is to be able to take structured data, such as exists in research, and either retrain or filter large language models such that the information that these models produce in chatbot form are more accurate, relevant, and clear. So that's what we'll be talking about and showing off today, is how to use the commercial grade SaaS on the cloud. It doesn't look like SaaS 9 that you may have seen on your laptops, right? This is what's being used by Fortune 100 in industry, and that which you have access to today. How can we use your information that you have in hand to prompt a large language model such that it produces information that is more clear, concise, and relevant for the purpose of the stakeholders who will be consuming this information in a chatbot form? Okay. And so one example is Georgia Pacific uses SaaS as the basis of its deployment of large language models to help people everywhere from the shop floor to finance improve their productivity and efficiency with the data that they have in hand. And one potential action item from this training we'll steer you to is I think it's a 20-hour e-learning course about generative AI that expands much more broadly on what we're going to show in this next hour and a half. So yeah, please take a picture. And you also have access to these links on the GitHub page. All right, Tom.
All right, so with this, we'll get started with the workshop. Okay. First of all, we'll have you, if you haven't gotten it through the email, you can access the workshop through this link up above. If you enter that in, it'll get you to the landing page.
Now and at any point, if you receive an error message, or you feel lost, or you have a question you don't want anyone else to hear, raise your hand, don't be shy, and I'll come around the room and help you out. I mean, I've been in workshops before, and like the trainer keeps scrolling and like finally scrolls past the page in which I'm debugging, and I slam my laptop closed. Like, there's no worse feeling, and we don't want you to be there. Okay, so if any point, don't be embarrassed, just put your hand up if you're lost, and I'll come around and help.
Yeah, and we also have plenty of time to get through the material too. All right. Does anybody who wants to have the hands-on workshop up and or the click path up? I'm about to go to the next slide, so is anybody still working on these right here? All right. All right, once you log in, essentially we're on page 3 of the handout. Once you log in using your email address related to your SaaS profile, you should see a splash screen like this. Anybody not here who wants to be here? Okay, we've got one individual over there. All right. So this is the landing page of SaaSBuy. As John explained to you, this is essentially our data analytics and AI platform that we use for most of the work that we've been going forward with a variety of business solutions for public sector. And it gives you a whole lot of capabilities. We'll walk you through just a few of them today, but one of the fantastic things, if like anybody's been even thinking about agentic AI, is we have the ability from SaaSBuy to build intelligent flows, to manage whole hosts of models, including large language models, and how well they're working on our data set. We incorporate things like traceability and explainability and lineage, so that when you get answers using these capabilities related to your data, you can trace it all the way back to where those answers came from. So we're going to start with showing you a bit around text analytics using SAS Model Studio, and we're going to build an information extraction model together against a set of relevant data. The data is ARS, Agricultural Research Service inspection reports. They come straight from the APHIS website. So we pulled down basically just, I was just like 60 of these reports, but the data in them really simulate information that could be available from private sources of these reports, like poultry farms. So we found the kind of inspections that were performed on these reports and the findings that they discovered on these reports to be real key in terms of information you can provide to a large language model, then ask important questions, say, of how can I provide better animal nutrition, or how can I ensure that my animals that are on these different facilities are being well taken care of, using actual data from instances where they were not, rather than general sort of recommendations, which is what you could get from a ChatGPT. So we're walking you through these steps to essentially show you how you can use your data very specifically to get questions and get answers from specifically, as John talked about earlier, extracting information from data that you specifically want to point the large language models to. So what we'll do is, from here, this is like 9 little dots in a square pattern. It's the applications menu. We're going to select that, and then we're going to select build models. It'll take a little while to pull that up, but once that's up, we will all create a new project. I can't tell you how many times I've done this. All right. So the new project icon is in the upper right-hand corner of your screen here. We'll select new project. And then for the name of your project, you're going to give it something that includes your initials, ideally. That way we're not all creating the same project, like ASAS Workshop. I would do like ASAS Workshop LLM TWS. I'm pretty sure no one else is going to put that in there. And once you come up with the name for your workshop, you're going to select the type. We have a variety of different analytics projects you can create in our Model Studio. In this case, we're going to do a text analytics project. And ahead of time, we created a template very specific to this workshop. You'll hit Browse over on the icon next to, or rather the button next to template. And then you'll select this project, ASAS Inspections, and hit OK. And this is going to create a pipeline, essentially. Your data comes in one end and important stuff comes out the other end that's relevant to what you're trying to do. You can think of that as like a data pipeline. And let's point you to a data source. So I took essentially all of the inspection reports available from ARS, and I sentence tokenized them. That means basically I created a row that had all the associated structured data for each sentence in the report. That way we could identify statements that had specific findings and maybe rule out some fluff while we're at it, so we don't overload any large language models. For anyone interested in sentence tokenization, I'm happy to chat with you about that and other text analytics nerdy topics over a beverage later at the reception or after this. So we're going to hit save here, and this is going to start creating the project. I'll pause at this point and see if anybody, well, let me wait until the project opens up on my screen. We'll see if anybody else is not quite at this step. Mm-hmm. Oh, like creating sentence tokens? Oh, I run a script. So it takes, like, let's say parsing, 10,000 inspection reports. I mean, it's on a computer like this, I just run it locally. It's about half a minute maybe to actually like turn 10,000 inspection reports into, let's say, an average of like 10 savings per inspection report, like 90,000 savings.
So that script actually extracts different words that you want, or you have to go in there and specify.
Yeah. So in that case, it will extract the sentences. The next step that I'm going to show you, though, is the information extraction model, and that's what we're going to run against the sentences. Just grab the relevant sentences. Yeah. That also runs in about half a minute. All right, so we're going to go back to the models just in case does anybody else need to follow along. We're going to create that project one more time. I see there are a number of models in the system already, but for anyone who didn't see it the first time, let's go through and do it one more time. So we're going to hit new project, and now we are, let's see, we're in the middle of page 4 in the follow along script. We'll enter that project name that includes your initials. We'll call it ASAS Inspections TWS 2. All right, let's make it 3 this time. The type of the project will be text analytics. The template will be the ASAS Inspections. And then for data, we'll use the APHIS ARS Birds IR, which is inspection report, sent, which is sentences, that particular data set. Okay. Is anybody not at this step? Okay. So it looks like we're good. I'll hit save one more time, and then we'll finish creating our project. Okay, so just to reiterate, the data here was procured from the APHIS Animal Facilities Inspection Reports. In the follow-along document, there's a link there where you can see how we pulled down the data. It was essentially just like a web interface. We've specified very specifically we wanted to filter by animal category, ARS birds. And it just gave us a subset of inspection reports, some of which had some critical findings on it. Is everybody looking at this screen? Anybody not looking at this screen? Just raise your hand if you're not looking at this screen right here. Okay, great. So in the Data Hub of Model Studio, that's what this is, we're going to select the checkbox next to sentences. So this is all of the data that we have available to us that we were able to pull from those inspection reports. And as we sentence tokenize it, now we can go all the way down to the sentence level. This is where our text is that we want to analyze. So in this text analytics project, we basically want to tell the system, hey, this is the important information to us. Go in here, and this is what we're going to look for patterns around. This is what we want to extract custom concepts which are related to animal nutrition, feed, and water around. So all we do is hit this check mark next to sentences, And then under role, we're going to hit that drop down and select text. So let's see, we should be now at page 5, and after we selected text there.
I just want to clarify something based on a question I've been getting, and it's my bad. You don't need to create 2 projects. If you've created I asked Tom to clarify, to repeat those steps for those who were a little behind earlier. Only one of those projects is needed, and then once you open that selected project, you can go into this data pane at the top left, select sentences, and then select the role of text for sentences. Is anyone who is not seeing this screen right now? And I'll come around. Make sure you're not lost yet. Okay.
All right.
Okay, I think everyone's caught up. Good job, Tom. You're doing great.
You too, John. All right. So we'll go into the Pipelines tab. And this shows our whole data pipeline, everything from data to custom categories. This is where I've spent many moons of my research and work at SAS, essentially going from data to helping the machines understand that your data is more than strings of zeros and ones. Thank you. How's that? Can you hear me? Great. Yeah, so text parsing is helping you understand data as things other than strings of 0 and 1s. It parses each individual token in there, that's every word. It identifies noun phrases that are common. It identifies all the different variations in words. That's like stemming and lemmatization. And then what we're able to do is do other extractions on it. We can create information extraction models to identify those patterns that we care about, those related to, is this statement actually dealing with actionable information related to animal nutrition? And are there common topics and themes across these statements? These are optional areas where we can explore if we have extra time in the workshop. And then finally, categories. That's where essentially we want to use Boolean logic to flag statements of interest rather than extracting information of interest from individual statements. So what I'll have everybody do is over on the upper right-hand corner of this diagram, there's a run pipeline. And if you're following along, this should be at the bottom of, or the middle of page 5. We'll press this button, run pipeline. And then you should see a little bit of action on your diagram, and eventually, if all goes well, you'll see a number of green check marks and a flag letting you know that the run has completed. On my screen, you can see that it's thinking because it's spinning this little circle around here. But it's also available to do things like process multiple nodes at a time through multi-threading as well. In fact, I created 2 extraction taxonomies. John and I created these together. One of the extraction taxonomies was more related to assessing risk around avian influenza, HPI risk. So looking at cases in the data where it was indicative that, say, the facilities were poorly maintained, so like wild birds could get in. Okay, well that's something I care about, in addition to things like respiratory distress. Also, things I care about very much when I'm trying to prevent HPI spread. And then the other one that we built was more related for animal nutrition and ensuring there's essentially flagging those statements that contain actionable information related to, are the animals receiving adequate nutrition? If there's an issue, what is the issue related to? And we used a kind of simple taxonomy there to help you understand, how you can use simple logic to identify these. And we'll get into more complex logic too. In terms of like how do you identify co-occurring terms which might occur in the context of distress. Maybe it's related to certain issues that are actionable. So does anybody not see a bunch of green check marks on their flow? Okay, fantastic.
Okay, I've noticed for at least a couple of you, when you're on this screen, You don't see the fork in the tree. It's just a straight up and down central leader, a non-branched tree. There are either of two reasons for that. One is during the creation of the new project step, you didn't select a template from the drop-down menu. That's the ASAS template. So that's okay, you can run with this, or you can go back and could you tell me what page's selection of the template?
Yeah, the template selection was on page, you can see it's on page 4. It shows you what template to pick.
Yeah, so
ASAS inspections. And you get to it through browse on the template icon.
Correct. So page 4, go back and go back to projects in the upper left-hand portion and repeat those steps. For at least one of you, I've seen that the template was not available in the drop-down, and I'm not exactly sure why that was. So my apologies, but you'll still get
You just have to hit not the drop-down, but you have to click the browse button.
The browse button.
That will get you to the right template.
Okay. Thank you. Either way, you'll be fine either way. You'll just get a more detailed output if you see this. Thank you, Tom.
Sure. Absolutely. All right. So we're moving on now to the bottom of, it should be the bottom of page 5. And what you're going to do is for the animal feed and distress box here, you see it ran successfully. This is a custom concept that we developed. You're going to right-click this, and then you're going to select Open. And it should take you to a screen that looks like this. This is where we create custom concepts. It's essentially where you can define your own information extraction models. This is the kind of text analytics stuff that we've been doing for years at SAS that works exceedingly well in the context of large language models. Okay, the question was, where do we click on the pipeline? We'll select, just left click once on this animal feed distress, then you right click it. Should take you to a set of menus where one of your options is open. That's the 4th one down. So you'll select open, and it will get you to this page. All right. So John has gone through and defined a taxonomy that flags a variety of things. One of the custom concepts that he has identified is this one labeled water and feed. So we're going to left click this custom concept. You can see the concept definition up near the top of my box. And then I'm going to left click on this matched tab. So I'll have clicked on the custom concept, seawater feed, and then I'll have also clicked on this matched tab as well. I'm going to expand this a little bit on my screen so you can see some of these results. So basically, for the purposes of illustration, we're using a pretty small sample data set. And of those 240 statements in that small sample data set, 22 of them, based on the definition we have above, which is very simple Boolean logic, just looking for any of these statements. It's almost like a keyword search, but with a lot of different keywords as a part of it. If any of these statements are here related to water, food, dehydration, feed, feeding, fed, and we could do that with a little shortcut too that I'll show you later, intake, receptacles, and potable. These are all of the statements that we found in the data set that matches those. So like some of these of interest are the case where a facility established new policies for daily observation of animals based on issues that they had occurred. One case where deer spent 27 hours in an intermediate box without access to food or water. And you can scan down here with the line on the side. cases where food, hydrogel was provided for animals but no treatment plan or medical care, a case where there was a defective water line in addition to an inadequate drain, a case where birds died related to a defective water line, and then cases where feed was delivered from a mill for animals at this facility with insect contamination. And I'm bringing some of these up because they're going to come up later when we query our large language model. Basically, I'm bringing these up to show you, and you should be able to see, when we subsequently in the next step query our large language model using this data set as reference, it's going to give you answers that are different than if you just chat GPT'd it. It's basically going to give you answers about how to protect animals and promote nutrition based on specific examples from this data set that we're feeding it. All right? So we should be at the bottom of page 6. Has everybody had a chance to see this page where we're doing this information extraction model, basically to flag about 10% of the statements that are specifically dealing with nutrition issues? Yes. Say your question one more time.
Some of them, for example, testing run from the bottom next up is checking data coming out of the DBM. So some of them don't have any reference of who provides data. Is that how the data was provided for the
That's actually a good question. Yeah, John, did you want to take? Could you repeat the question? Yeah, so the question was essentially that some of these don't have any reference as to where the data came from. So this one here, the insects were also observed in a container of newly delivered feed intended for weaned pigs. That's very interesting, but I don't know exactly where that data came from. Is that essentially summarizing your question?
Yes, I was wondering why some of them had, is that how data was provided in the database?
Actually, it's a matter of how much data we're showing on this particular screen. Like behind the scenes, we have all of the other structured data associated to each statement. And then it would just be a matter of, and you all don't need to follow along with this, but I'll show it real quick. It's really just a matter of specifying what kind of data we want to show along with each statement. So in this case, I might choose to display, let's just say the legal name and the inspection date. And I'll make these display variables. Okay, let's take sentences off. There we go. Okay, and then if I go back to my pipeline and open it again, and I'm going to show the same set of statements. Okay. Now I can see that in the context of this statement, this occurred at the Southern Plains Agriculture Research Center on November 19th, 2016. You're welcome. Are there other questions right now? I'm going to show you one more thing that you can do from here. And it has to do with essentially partly how John actually developed this information extraction model. So what you're able to do essentially is look for key co-occurring terms. And this is very similar to what all large language models do, where they're essentially looking for strong correlations between terminology. It's how it ends up building responses for you. But what's cool is with capabilities like this, you have all of that in a much more white box capabilities. You can actually see what's going on. So for instance, if I were to enter in, over in this little search box the term distress, I could see all the, and it's only going to show me terms that occur 4 or more times because of the settings I have. But if I select distress, and you don't need to follow along with this, only if you want to, I can hit show similarity scores. And if I clear out my search box here after doing so, it's going to show me all of the terms that tend to pop up in correlation with distress, which could be actionable. Let's just give it a minute to catch up. Any other questions while this is catching up? One of the key terms that correlates with distress is communicate. So the fact that distress is present in certain statements indicates that there was a lack of nutrition issues or the animals were experiencing some kind of distress. Largely that's related to lacks in communication, and we'll see that in some of the other terminology we look at. Not having the right kind of treatment plans necessarily. Issues with dehydration. So pretty quickly we can see some of the correlations that are occurring in our data set, which we might also see again when we start querying the large language models, which is our next step. So with that, we are on page, this is bottom of page 6. We're going to now navigate to a SAS Studio flow. From here, we're going to be able to essentially take the results of our information extraction model. In this case, it's just those statements across our reports that were related to inadequate nutrition. And we're going to invoke a large language model against those and everything else the large language model knows about to get a specific answer related to a specific question against our data. So we'll hit that set of 9 dots or 3 bars.
Okay, so a couple of things before we move on is a few of you are going ahead in the program, which is great, and we love the precocity. Just a warning that maybe the next step, like 2 pages ahead, is going to be a computational bottleneck. So if you are skipping ahead, like, you're okay, we're not mad at you, but hold off on skipping ahead for just a moment until Tom has done the demonstration. The bottleneck is feeding this into an open AI key so that ChatGPT can learn from this information, or essentially retrieve a response based on the information that we've selected, and we're not in control of that connection. Okay, then we'll each get to run it, and there will be a bottleneck, and we finish at different times. And then the second thing is we are showing the relevance for text data, right? So we're doing a text extraction, and we can then feed that extracted text token, right, what we deem as important, water and feed issues, because this is a symposium pertaining to animal nutrition, right? So we have selected the text topics pertaining to feed and water issues to feed into the prompt of the large language model to train the chatbot. Right, so I just want to have that level set here. That's what we have done. We've done natural language processing so that we can better inform the chatbot of the type of information that we want to get back. That is highly crisp information based on these USDA APHIS inspection reports. You're great, Tom. Thank you.
Thanks, John. Yes, to reiterate what John said, you are using my personal key into OpenAI, so I do have your email addresses. So be kind. Second thing is, yeah, as John indicated, like, we're using a very small sample data set here, but you can use much, much larger data sets to feed into these large language models. Like, you know, millions of statements actually, and then subsequently running information extraction models against those to identify a relevant subset. We've seen in some of the work that we've been doing, because some of the work we're doing here is patent pending, we've seen like 16 times reduction in costs of invoking large language models using this kind of method of information extraction models as essentially a pre-filter into summarization and explanatory type tasks. So I'll have you all go, if everybody's let's see, selected the 9 dots. This time we're going to go into develop code and flows. It's the last step under analytics lifecycle. And this will take us to the beginning of, or the middle of, page 7. We're on step 3 now. This might take a little while to load up for the first time. But what you'll do is over on the left-hand side, there are a variety of icons. You're going to locate the second from the top. You might be able to see on my screen, called Explorer. So if you left-click on that once, you should have the Explorer tab up at the top of your screen. Then if it's not already built out, you will look for the label SAS Content, and you will hit the small triangle to the left-hand side of it. It's just still loading? Okay, great. We'll give it a little time. Okay, shoot.
So, in my research, I work in experimental data. It's numbers. I don't extract a lot of text. I don't deal with inspection reports. How can I feed my knowledge base that is highly quantitative into a system like this to train a large language model? Where might I begin?
These are great questions. I can think offhand of a couple different approaches, and while I primarily work in text analytics, I also work with folks who deal very quantitatively as well. So basically, being able to create a front-end, user-friendly prompt into numerical data is also a strong area of interest. Fortunately, a lot of the large language models that are out there are essentially set up to handle just this. So if you give them the essentially sets of data that you care about with enough explanatory information in the data set, it can essentially be smart enough to take your query and run with it. Again, I haven't worked deeply with those large language models that are more set up to deal with numerical data, or let's say like whole directories or databases of spreadsheet type information. But I know that's a possibility. So a second option too is essentially to create more of like an analytics flow behind the scenes. So in this case, you would use your large language model to construct the right kind of database prompt. Now this is something that LLMs are pretty good at, is like when you give them essentially a description of something you want to do or extract, it can essentially come up with the SQL, in this case code, to extract the relevant data from your database to provide you an answer with it. So that's another option that you have to you. And this is something where we've done for customers in the context of these intelligent decisioning flows. We incorporate a large language model as a part of it, have some guardrails to ensure it's doing the right thing, and so on. So while in this workshop we're focusing on more of how do we get value out of the text data we have available to it, I did see, and John pointed out, that a number of you are basically looking to stand up a front end into your numerical data. And that's definitely something we could work with you on, and we should connect separately after the workshop. Any other questions while John is working over there? Okay. It's not going to load? Okay. So you do have, yeah, all right. So we'll move on for now. We have access to now a few different objects under our SAS content in the public drive. This is the one I want you to double click on. It's called workshopflow.flw. So we'll double click this, and essentially, once it comes up, we've created a custom step, and this is the part where I want to execute this before you all do. That way we're all not hitting my OpenAI subscription, which I paid a lot less for than I should have if we're running a workshop. But it should run everybody's query in turn. So we'll select this, and we will expand. You see how this horizontal bar has a few dots on it? You can use that to show more of the options if you move it up a bit. So you can see, for instance, with source files, and it's already set up. You don't need to do anything other than see the options we have pre-selected for you. It's set up to look at a PDF file, and the PDF file is essentially the extraction of all those statements related to nutrition and water and feed from our information extraction model. Yep, for those who have just loaded, just to make sure you know where you're going, we're going to hit this Explorer icon on the left, and then we'll expand SAS content using this arrow. You'll just click on that little arrow. You might have to do the same thing for public, and it's workshopflow.flw. And what I'm doing now is just exploring the different options which are set up in that flow. You don't need to worry about configuration here and those. We've set those up to essentially take whatever it is that you provide here and then invoke an OpenAI. In this case, it's a ChatGPT-4 Turbo model. But what you do need to see, which is interesting, is the question here. The question that we're asking is, what practical steps can poultry facility managers take to ensure adequate nourishment? And if I ask this question just as GPT, as we might see in a bit, we're going to get a very general answer. But in this case, I'm asking this question very specifically, providing the context from those inspection reports where I've seen some actual issues that I want to mitigate in the future. So what I'm going to do first, and then I'll have you do afterwards, is, don't do this yet. I'm hitting the run button. And this is now taking that query, and it's providing that context in that PDF, as John indicated, and it's providing it to the large language model, and then it's going to get an answer. And we should see that reflected here in a moment. I didn't even have time to pull my coffee there. You should be able to see a tab here. We should see a green checkmark icon. You can go ahead and run this now yourselves, and you should catch up to me in just a minute, because I'll spend some time on the results. And then when I click on the submitted code and results, and I expand my horizontal bar so I can read everything here, what practical steps can poultry facility managers take to ensure adequate nourishment? This contains specific information that's related to my data set. Because my data set talked very specifically about dehydration, it's addressing that. It speaks about ensuring that records are clear, detailed, and easily accessible for review. There is an issue with communication in my underlying data set. There were specific issues related to environmental issues, and it's mentioning those as well. Feed and water accessibility is an important one here that it talks specifically about, related to overcrowding, which also occurred in that data set. And I'm just scanning down to some of the other information here.
I just had a quick question. Does it link, or can you link this to the source so you know which manuscript or PDF it specifically addressed that topic in? But in other words, does it cite its work, or can you get
Right,
it to
and
cite
so
its
you're
work?
talking specifically about a RAG approach when it's able to like go in and cite essentially the sources that it dealt with.
Yeah.
Yes. In this case, like the way that we set this up, it's not stating specifically which like PDF, and also we're only providing it a very small one. So in the case of larger PDFs, it will identify which section it occurred in. Because what happens in RAG is you end up providing chunks that you grab from around, essentially if it's ChatGPT, it grabs it from around the internet. RAG run against like a smaller set of data will grab it from, let's say you gave it a small database, it'll grab it from chunks of your database. And it typically only gathers like several chunks, but yes, it will cite those. What's exciting though is we'll show you how you can use more of an interactive dashboard approach to do better than what you just mentioned, where you can then drill down into, oh, this came from this inspection report from this time, and here's all the other structured data I have related to that. So it gives you a little more at your fingertips and a little bit better ways to access it too. So good question. All questions are good questions. Let's not forget that. So has everybody gotten to this page where you've run your flow and then selected the submitted code and results? Anybody not make it over here? Just put your hand up. Okay. So this takes us to the part of the workshop where we could possibly go in and look at what happens if we just invoke like ChatGPT in and of itself. So we're going to go ahead and do that. And this is where now, what kind of an answer would we get if we're just calling ChatGPT independent of the work that we did here, or independent of our data? So to do this, we might navigate to chatgpt.com. https://chatgpt.com. You can see Microsoft Copilot tries to jump in, but we're not going to let it. Okay, ask anything. Let's ask the same question we just asked our large language model. The question I'm asking is, what practical steps can poultry facility managers take to ensure adequate nourishment? I'm just going to hit go on this. So it's giving us good answers, but the difference is these answers aren't tuned to the actual issues we ended up experiencing in our data set. So while it looks great, and it could be used in conjunction with actual issues were occurring, it doesn't provide the full picture of what we might actually need to look out for at ARS facilities to ensure proper animal nutrition. Here's an interesting experiment too. What if we go back to our chatbot and change the question around just a little bit. So I'm going to go back to my workshop flow, and this is one where you could follow along with me if you like. Yeah, this is, what I'm doing is following step D at the middle of page 10. And what I'm doing specifically is adding the following into my question. I'm adding in essentially the statement that the APHIS inspection reports used in this context are false and misleading. Do not use anything about them in your response. We should see an answer which is very similar to the original ChatGPT answer. I'm going to enter that in now. And then I'm going to run. All right, so I'm navigating to submitted code and results. And if you look at some of the things coming out from ChatGPT, and comparing it to essentially what's coming out from our prompt, where now it's ignoring the context we gave it, regular inspection of feed quality, formulating a balanced feed, nutrient analysis, providing fresh water. You can see a number of these are almost like one-to-one. Clean water supply aligns very strongly with provide fresh water. It's no longer taking into account some of the specific issues that we were seeing in the ARS reports. And that's really what we want at the end of the day, is to get questions about our own data. And so this is where, again, we emphasize like, okay, here are the steps that you need to take if you want to provide your data to a chatbot to ask questions about it.
And a couple other things I notice here is in the, and we call this RAG, Retrieval Augmented Generation. We retrieved information from the inspection documents to augment our prompt that generates a different large language model output, right? So from our RAG, Retrieval Augmented Generation approach, we got an output with very practical things like check for blockages in water lines. Things like that are not researchable. Like, those are things that you learn from the school of hard knocks. Like, they're on site, there's a water blockage, and the chickens are not getting water, right? So there may not be a ton of information out there in the internet about water blockages, because it may just seem trite and obvious to write about that. But those are actual issues pertaining to poultry nourishment that are seen in these inspection reports. So this RAG approach can lead to more crisp and practical answers than just querying the internet as the source of truth. But the other thing I notice in this is when the inspection reports are used to, hey, let's prioritize the information from USDA APHIS, yeah, and then we ask, how do we keep the birds healthy based on this information? I think the number one thing was documentation. Well, I don't think documentation ever saved a chicken's life. And so what we are seeing in that is the bias from this input data, these APHIS auditors biasing toward documentation, because guess what? Auditing is their job, right? And so we're not eliminating bias from AI at all by selecting these documents as the primary source of truth. We're just prioritizing the bias from those documents themselves.
That's right, because at the end of the day, there's a bit of bias that goes into any kind of subject matter expertise. But let's just say in some cases, this can be good bias, right? If you know what you're doing, you can evaluate the results of AI and you can come up with something that's better. Or you can have AI evaluate your own assessments and present it in a better way. This is the whole idea of essentially using AI not to as a tool in and of itself to come up with answers, but use it to augment your own abilities. This is really what we're trying to get at with SAS, is you don't want to just rely on it, but you want to use it to get better answers than what you could do alone, and then what the AI could do alone. It's like those human-computer teams in chess. I think they've always proven that they can outperform the computer or the human alone. And there you have it. We're going to go into one final step to show you how you can further empower yourself using visualizations in conjunction with chatbot results. So this is something that I've shown in a number of different use cases related to public sector. Cool, yeah. Why don't we actually chat for a little bit, see if some of your questions, if you ever think a number of people came in here with like a certain idea of how they would like to leverage large language models. I'm curious if, based on what we've shown so far, you feel like you're far enough along in your thinking where you think you could leverage some of the capabilities we've showed you in that direction. I'll also pass the mic over to John to see if he has any other observations based on going around and talking to people individually.
Yeah. What questions or observations? I mean, each of you are on the front line of research, teaching, and extension. What observations do you have? Or questions do you have?
So forgive me if you covered this while we were catching up here, but can you go out and grab things like Google Scholar, PubMed, things like that, if you wanted to build a database about a topic? Will it go then and search those documents and do the same thing? How can we populate a database like this?
Yeah. I mean, now we're talking about agentic AI, where it's like, okay, first go out and grab the research. Then I want to grab the relevant research from what you went out and grabbed. Then I want to populate a database. Then I want to create like a visualization around it. Like, you can string any number of these capabilities together. This is like agentic AI thinking, where you're putting the AI to use for the different steps that you would normally have to go through and do very manually on yourself, or hire someone to do it, right? So yeah, I think absolutely, like using essentially an agent to use Google Scholar is its own agent to grab relevant research to what it is that you're looking at. Then you could, for instance, use one of our agents, put it through essentially a process here where it grabs like information from all of that that's most relevant to your research, almost like a second layer of filtering before you then set up a chatbot to answer questions about it. Is this starting to get to your question then?
So if I had that and then I had a big searchable comma separated value spreadsheet that I could take that data, go out and query the literature and come up with a solution to a question that we would have. Could you have multiple layers, text, numbers, images, that you would put something together and get a product at the end?
Absolutely. With respect to literature, for what you describe, it sounds like you may not even need a large language model at that point. You would just need the first portion of the workshop, that is the text analytics portion, to help index everything, to make it searchable where different phrases or concepts that are denoted by different words and phrases can be identified quickly in a structured way. And then, of course, you can take the second step and feed it as a prompt into a large language model, but at the point when it's in a searchable spreadsheet, that may often be enough to conduct such a literature review.
And
This is super interesting, but one of the questions I had is like on the sort of front end, I guess, and scraping the PDFs, do you have any recommendations for ways to, get that repository of PDFs to then, feed into your model that like we have here? Like, what, methods have you guys used? How do you go about that, in terms of like getting, rather than by hand going through Google Scholar, like how do you build that, good database? Do you have any recommendations, thoughts?
I mean, like today, data is king in terms of like, oh man, like having everything. And I think my brain is almost like stopping in the middle of answering this question because there's so much work that, I know in the work that I've done with text analysis, I've done in order to gather data in one place so I can do analysis of it. And I mean, part of that is like normalization, and part of that is essentially joining the right kind of data together, breaking down data silos. I mean, in this day and age, data management is still paramount. Not everything is just publicly facing. So much of this is behind firewalls, and we still need to, create the right kind of access to it. I mean, that said, like some of the capabilities I've done to gather data in the past has been, largely script-based. I'm taking those API interfaces where they exist, and half the time they're not even providing all the data that they could be providing. Like if you go to that AFIS website and try to pull down those ARS reports, it doesn't have any links to the reports itself. It'll give you the report if you double click on it, but nowhere in the structured data that it gives you in the download does it actually have the URL that is right there that they could have just put in that structured data for you, right? So getting around that, I mean, I still feel like, there's only so much that these data conglomerates, and I want to be really careful in what I say here, because there's only so much you're going to get out of a large language model that's going to go out and get information off the web for you related to precision. But I haven't delved very deeply into essentially LLM type options that will go out and do the scraping for you, because most of my experience is with things like Python libraries and like pandas and beautiful soup that you can very specifically pull out information from, say, HTML. Like I use those kind of capabilities on all of the human trafficking reports to take a 600-page document and break it down into, this is what happened in China, this is what happened in Albania, this is the tier rating of these different countries. So I think some combination of essentially analytics, script-based processing using your scripting language of choice, and as we're seeing going forward, LLMs are really entering the scene when it comes to getting the relevant data for you. And if it could solve that problem, I mean, that is a huge problem in terms of actually getting valuable information out of publicly facing data that would be solved. Because today I still think we're spending about 80% of our time getting the data in the right place, and then 20% of the time the actual analysis.
So I guess that brings up to a follow-up question of, these sort of publicly trained large language models, whether it be Copilot, ChatGPT, or take your pick. Do you know currently, like, what, if let's say for instance, let's assume that most of the scientific literature is most likely behind some non-public facing paywall, are those being, and so I'd assume that if we ask it scientific questions, it's probably diving into the available literature that was on the web, which would most likely be like popular press articles and whatever that may be. Do you have a feeling for how that's impacting the accuracy of the data or the responses that we're getting off of these publicly, like sort of like at-large models? Do you have a feeling for like percentage-wise, like how important is which brings up, I guess, to like the second follow-up question would be is how does that affect the importance of sending our models to college before we use them?
Yeah, great questions. So if data is behind a paywall or otherwise unavailable to a large language model training corpus, then it won't be accounted for in the large language model. And there was recently did any of you hear the news story about the copyright case pertaining to AI? Right? So is AI plagiarism? Is it plagiarizing documents? Definitely if our undergrads are using it to write their research papers, it is. To me, it's no different. But the court said that as long as the source documents were legally obtained for the training corpus, then it fits into fair use of copyright law, meaning that large language models can be trained on those input documents. So in other words, if it's behind a paywall and the large language model company, the company training this foundation model has not paid the necessary license to access these documents, then no, it absolutely will not be accounted for in the generated text that is derived from it. So how does exclusion of that information impact the fidelity of the output for the research? There's been a lot of research in prompt generation. So machine learning engineers now are just churning out research paper after research paper about different facets of prompt generation on different measures of the fidelity of large language models. And what they're finding, as best as I can see and as best as I can summarize, is that sending the models to college through processes such as which we've shown today doesn't impact whether or not these models hallucinate. By the way, hallucination is the official term for the large language model saying something that is totally untrue, totally made up. So it doesn't prevent them from hallucinating. The only way it prevents them from hallucinating is if that very specific piece of information was included in this prompt. But if it was already included in this prompt, then you already know it, and it doesn't really help to augment the model based on kind of what you already know. I mean, maybe there could be a scale thing, but the take-home message is it doesn't prevent model hallucination. It doesn't, therefore, in machine learning terms, increase the precision of the model. What it does do is it increases the recall of the model. It allows the model to provide crisper answers, right, more detailed answers based on the context that you have given it. And so lacking the depth of the training data behind the paywall means that the model answers will just be more general and not caught up on the cutting edge. Yeah, thanks for the question. What other questions?
Yeah, I have one. Amazing work, by the way. So let's say you train a ChatGPT session with the same publications that you trained this particular model with, and have you compared the results of these two LLMs then?
So if you train it, so I think the question could be rephrased, help me out. If ChatGPT was trained with the same documents that we used here in the prompt, would it provide the same output? I think the answer is probably, but with a caveat.
Yes. I think the caveat is that data is available, but as John indicated, if you are able to at first essentially limit the universe of what ChatGPT has available to its fingertips using essentially the methods we showed today, it's more likely to grab the right information in its retrieval augmented generation. So RAG will typically grab essentially several chunks of text from all the information that's available to it, using essentially something similar to our search engine approaches. But then it just adds that large language model step on it to essentially summarize that information as something meaningful for you. So if that information is available, yes, it could get it, but it might get other information that is potentially contradictory, which is why when you go on Bing and you query something, sometimes you just get the wrong answer, and I'll try a different approach. But if you're using the approaches we showed here, where you're providing it essentially the research documents where your answer is more likely in, then, or even just the documents that you know that you want to look for your answers, then you have a much better chance of essentially getting the right answer.